Hello dear friends, welcome to my channel. Today's discussions is geodesic curvatures. Let C u to the power alpha u to the power u power must use superscript alpha and u superscript alpha is be a curve on S whose metric is given by ds square a alpha beta a subbase alpha beta and du superscript alpha beta and du superscript beta. Okay, so following the line of thought as described, a subbase alpha beta and lambda superscript alpha and del lambda superscript beta and del s. Okay, this is the Einstein summation conventions I have already told in my differential geometry class. Okay, so if del lambda b and del s does not equals to 0, we introduce a unit vector of the co-directional with del lambda superscript beta and write del lambda beta superscript beta and k subbase g and eta superscript beta, and where k subbase g is a suitable scalar, we choose the sense of eta superscript alpha in such a manner that lambda superscript alpha and eta superscript alpha. So epsilon alpha beta, lambda alpha beta and eta superscript beta is equal to +1. Friends, you have already known this kind of these facts in my videos. Which video? Sadet-Frenet formula. Yeah, formally you know that formally you know this equations. Okay, it is coming from Sadet-Frenet formulae. Please watch my this video. And the scalar kg is called geodesic curvature of C as E alpha lambda subbase beta alpha and eta superscript beta and E epsilon superscript alpha beta and eta superscript subbase beta is equal to lambda superscript alpha, and we see del eta superscript beta and del s and equals to epsilon superscript alpha beta and del lambda subbase alpha and divided by del s and alpha epsilon. This is the equations. Okay, I hope it is clear, and please write down, and this is the kg. Okay, so this is called geodesic curvatures. Okay, k subbase b g, k subbase g is called geodesic curvature of C. So I get this value, and must remember finite formulae of C lines. Now you have to know that the necessary and sufficient conditions for a curve on a surface to be geodesic is that its geodesic curvature be 0. The vector limit q tends to p and pq ds is called tangent vectors denoted by lambda superscript I, because you have already seen that the formula which I have told that del lambda beta superscript beta del s. So this lambda but lambda alpha a subbase alpha beta and lambda superscript script alpha. So lambda superscript alpha is a tangent vector. Okay, lambda superscript alpha is equal to tangent vector. You can check that this is the point of P and this is the curve C, and this is mu and nu, and this is the lambda. This portion is lambda. So in here normal vector is del lambda I divided by del s vanishes or orthogonal to lambda I. Any vectors is which is orthogonal to tangent vectors at some point of curve is said normal vector of the curve at the at that point. So unit vector directional mu superscript I is the principal normal vectors. This is the principal normal vectors, are mu I is the curvatures, and nu is a unit vectors. Nu is a unit vectors. Nu is called binormal of C at P. So thanks for watching. I hope it is clear for everyone.